Hi, in this video we're going to be looking at trigonometry identities. We're going to look at some past paper questions on this section. What is important for you to know is that for us to be able to work with questions of this type, you need to know all your trig formulae, from your double angle to your compound angles and your grade 11 trig formulas. So looking at this following question, it says prove the following identity. And we see we have a left hand side and a right hand side. So we're going to start with our left hand side. What we notice is we have two denominators, and what we got to do is find a common denominator. So we're going to start with what is the common denominator of cos x minus x and cos x plus x. And you'll notice that we're going to put it together. So our LCD is cos x minus sin x into cos x plus sin x. So the first thing we're going to do with our first term, to make the denominators the same, we're going to multiply the numerator by cos x plus sin x. With the second term, we're going to multiply the numerator, because the denominator is cos x plus sin x, we're going to multiply the numerator by numerator cos x minus sin x is going to be multiplied into cos x minus sin x. So let's repeat that. Here's our common denominator. So the first one, the denominator is cos x minus sin x. We're going to multiply the numerator by cos x plus sin x. And that will give us cos x plus sin x all squared. Then we're going to take cos x minus sin x, and we're going to multiply that by cos x minus sin x, and that will give us cos x minus sin x all squared. So now that we've done that, we are ready to use FOIL. Cos x plus sin x all squared. We can use FOIL, first, outer, inner, last, or square a binomial. And if we do that, you square the first term, you'll get cos squared x. You square the last term, you'll get sin squared x. Your middle term is cos x times sin x times 2. Double that. 2 sin x cos x. And then we're going to do the same thing. We're going to get cos squared x, but because of the negative in front, we're going to change the sign. So the middle term will be minus 2 cos x. Because of the negative, we'll change the sign, and we'll get plus 2 sin x cos x. And then if we square the last term, we're going to get sin squared x, but because of the negative, we're going to get minus sin squared x. So what I've done is expanded the numerator. Now we're going to group and find like terms. You notice cos x and minus cos squared x. Cos squared x and minus sin cos squared x will cancel. Your sin squared x and your minus sin squared x will cancel. And you'll only be left with 2 sin x cos x plus 2 sin x cos x, would give you 4. 2 times 2 is 4 sin x cos x. So we can write it as 2 times 2 sin x cos x, or 4 sin x cos x. And if we work this out, you notice 2 sin x cos x, that's actually a double angle formula. Just to recap that what you remember, from our double angles, that sine 2x is equal to 2 sin x cos x. So implementing that formula, that will reduce to sine 2x. And we also know that cos squared x minus sine squared x, coming from a double angle formula again, that cos 2x is equal to cos squared x minus sine squared x. So we're going backwards. The cos squared x minus sine squared x is actually 2 cos 2x. And then we can do, sorry, that is incorrect. Let me take my razor out. We cannot cancel that. But we know that sine over cos is actually tan. So sine 2x over cos 2x is tan 2x. And we bring down the 2. And if you look at our original question that we wanted to solve, we wanted to prove it 2 tan 2x. And we end up with 2 tan 2x. Okay, we're looking at the next question. And it says, consider the identity 8 sine 180 minus x cos x minus 360 all over sine squared x minus sine squared 90 plus x is equal to minus 4 tan 2x. So the question is to prove the identity. So I'm going to start with the left hand side. Now there's no need to rewrite the question. So let's work directly with the question. So we have an 8 in the front, and then you got sine 180 minus x. Remember, 180 minus x is in the second quadrant, and sine is positive in the second quadrant. So we end up with sine x. I am using the reduction formula. If we look at the next one, we have cos of x minus 360. So that's a negative angle. So what we can do there is add our 360, and then we end up with cos x. Going to the denominator, we've got sine squared x. And then we've got sine squared. So we won't worry about sine because anything squared is positive. All right. So we're going to get, but in the bracket, we have a 90 plus x, which is your co-ratio. So that will change to cos squared x. Now, remember where we're trying to go to. We're trying to get to minus 4 tan 2x. So looking at the question as we have it now, the top 8 sine x 2x. Sorry, 8 sine x cos 2x. I'm going to split up because I want a double angle. Remember, we know 2 sine x cos x is our double angle. But we have an 8 there. So if I want to break up 8, it will be 4 times 2. So I've created my double angle. And then we know sine squared minus cos squared. And we know the formula is cos squared minus sine squared. So I'm going to do a change of sign, pull out a negative, and call that cos squared x minus sine squared x. Now, using my double angle formulas, which we did in the previous question, we'll have 4 times 2 sine x cos x is sine 2x. And then we got a negative in the bottom, and cos squared x minus sine squared x is cos 2x. And sine over cos, we know we have a positive over negative is negative. We have 4, and sine over cos is tan 2x. And that's what we want on the right hand side.